Good day. This is our presentation for the sub-basin Pila, San Juan, Caliraya watershed analysis for time of concentration using velocity method. I am Leonilo Cabangon and my group mates are Bernarte Ron Irish, Alojacin Kate, De Los Santos Karlos Adrian Louies, Elaine Kristianne, and Mayo Hannah Princess. Introduction. Background of the study. Time of concentration is the time needed of water to flow from the most isolated point in watershed to the watershed outlet. It is calculated by the use of illustrated analysis of hydrograph and hydrograph data for some selected events. Hydrological responses being fragile to the unevenness of rainfall, preference of situation with the consideration of different depths, severity, and full length of precipitation are important to understand the behavior of watershed opposed to different patterns of inputs. Laguna de Bay is the largest lake in the Philippines that has surface area of 900 kilometers square and watershed area of 2,920 kilometers square. It has a capacity to hold at least 2.19 billion cubic meters and the lake's area watershed is about 3,820 kilometers square that extend to the neighboring provinces and towns. Objective of the study. Determine the number of rivers and its lengths within the jurisdiction. Tabulate the precipitation and estimated area of the sub-watershed. Create a hydrograph for the month of August 2021 for each sub-watershed like the attached examples. Determine the types of velocity, flow method to adopt, appropriate equation, and Manning's coefficient to use. Determine the water velocity, tabulate in Excel the assessed and calculated data. Calculate its concentration of each sub-watershed and the overall time of concentration of your assigned area. Next presenter, Velosan.
Scope and limitation of study. The following study covers three sub-basins of Laguna Lake watershed, which are Pila, San Juan, and Caliraya in the province of Laguna. The time of concentration was calculated from the 2-year period starting from September 2019 up to August 2021. This study will provide insights for the time required for water to flow from the most distant point in a watershed to the watershed outlet. This will be a great help to the residents in the locality to be aware and to safeguard themselves for the possible occurrence of flooding in the lowland areas.
Chapter 2. For Chapter 2, we were assigned to study Pila, San Juan, and Caliraya. Pila Sub-Basin is located in the southeastern part of the Laguna Bay Basin. It consists of 60 barangays in 6 municipalities, namely Pila, Victoria, Nagcarlan, Santa Cruz, Calauan, and Liliu. The Pila Sub-Basin has an area of 27.37 square kilometer and 21.93 kilometer perimeter. The total population in Pila Sub-Basin based on the National Statistics Office survey in 2007 is 112,164. Most of the population come from the municipality of Pila with about 39% of its total population, Victoria with 29%, Santa Cruz with 25%, Nagcarlan with 6%, Liliu with 0.23%, and Calauan with 0.07%. Next slide, please. San Juan Sub-Basin. San Juan Sub-Basin is located at the southwestern portion of the Laguna de Bay. The sub-basin covers the barangay of 2 municipalities and 3 cities, namely Municipality of Santo Tomas, Municipality of Malvar, Calamba City, Tanawan City, and Lipa City. The city of Tanawan and Santo Tomas have the largest land area within the sub-basin, while Malvar has the least. However, in terms of number of barangays covered by the sub-basin, Santo Tomas has the greatest proportion with 100%, followed by Calamba City 90.74%, Tanawan City 58.33%, Malvar 40%, and Lipa City 4.17%. Based on 2007 census of population by National Statistic Office, the total population within the San Juan sub-basin is estimated at 376,555. The Tanawan City, having the largest area percentage, making up the sub-basin, also shared the highest number of inhabitants with 38%. On the other hand, Los Baños contributes the least number of population at 0.39%. Next slide, please. Caliraya Sub-Basin. The Caliraya Sub-Basin is located at the southeastern part of Laguna de Bay Basin and about 105 kilometers southeast of Metro Manila. It is bounded by the Paete Sub-Basin in the east, Pagsanhan Sub-Basin in the west, the East Bay of Laguna Lake to the north, and Mount Banahaw to the south. 6 municipalities coming from 2 provinces are located within the sub-basin, namely Cavite, Kalayaan, Lumban, and Paete in the province of Laguna, and Mauban and Sampaloc in Quezon Province. The 38% of 5,685 or 5,685 hectares of total area is still unclassified. The 10% or 1,534 hectares is identified as municipal water comprising the man-made lakes. The whole sub-basin has an aggregate area of 13,526.21 hectares. Next. To analyze and identify the number of rivers and the length of Laguna Lake watershed, we used ArcGIS. Through the ArcGIS watershed analysis drainage command, all the depicted lowest elevation were considered as river and streams. For the gathering of rainfall data, the amount of precipitation was obtained from the World Water Online from September 2019 up to August 2021. The 2-year period rainfall data was considered for the calculation of time of concentration in the different river basin. This study only considered the August 2021 daily rainfall data for the plotting of the hydrograph. Next presenter, please.
Thank you, Ms. Elaine. For the predicted surface, runoff, and hydrograph, the predicted volume was obtained following the equations developed by USDA-SCS 1972. This is the equations for predicting the volume of total runoff of the rainfall excess or the volume runoff. For the equation 1, which is the Q is equal to P minus IA square divided by P minus IA plus SI, where Q is the accumulated runoff of rainfall excess in inches or millimeters, P is in the rainfall depth, SI is the surface storage, and for the equation 2, which is SI, is equal to K times 1,000 over Cn minus 10, where Cn is known as the curve number, K is constant, K is equal to 1 if Q and P are in inches, and K is equal to 25.4 if Q and P are in millimeters. IA is the initial obstructions in inches or millimeters also, and includes surface storage, interception, and infiltration prior to runoff. The initial obstruction term IA is commonly approximated as 0.2 SI. And we now come up to the equation 3, which is Q is equal to P minus 0.2 SI square divided by P plus 0.08 SI. Next. Okay. To calculate the volume of storm flow based on USDA-SCS 1972 equations, the curve numbers must be identified based on the surface description according to land use. The land use map was taken from Laguna Lake Development Authority or LLDA and Kyoto University, Philippines River Catalog of Hydrology and Water Resources Research Laboratory in Figure 2.2, which is the Laguna Lake Watershed Land Use Map. Next. Okay. Here in Table 3.4, we can see the curve numbers according to land use of Pila, San Juan, and Caliraya. And we use the composite and the data we obtain for the composite for Pila is 72.32, for Caliraya is 78.25, and for the San Juan is 83.75. Next. In 2.5, the determination of water velocity for shallow concentrated and open channel flow, the velocity method assumes that time and concentration is the sum of travel times for segments along the hydraulically most distance flow path as represented in equation 4, which is PC is equal to uppercase T, lowercase t1 plus uppercase T, lowercase t2, and so on, where TC is equal to the time of concentration and the uppercase T and lowercase tn is the travel time of a segment. N is also a number of segments comprising the total hydraulic length, the segments in the velocity method. And in the sheet flow usually occurs in the headwaters of a stream near the ridge line that defines the watershed boundary. Typically, sheet flow for no more than 100 feet below 100 feet before transitioning to shallow concentrated flow. Which, pakibalik po. Which T is equal to 0.007 for the equation 5, where uppercase T and lower T is the travel time and is the Manning roughness coefficient. I is equal the sheet flow length, and the P square is equal to 2-year or the 24-hour rainfall, and the S is the slope of land surface. Next po. For shallow concentrated flow occurs after approximately 100 feet. This is when sheet flow becomes shallow concentrated flow, collecting in swales, small rills, and gullies. Shallow concentrated flow is assumed not to have a well-defined channel and has flow depths of 0.1 to 0.5 feet. It is assumed that shallow concentrated flow can be represented by one of 7 flow types. The curves in figure 2.3 were used to develop the information in table 2.1. Next po. This is the figure 2.3, which is velocity versus slope for shallow concentrated. Next po. And this is the table 2.1 equations and assumptions developed from figure 13. Next po. For the open channel, the Manning's equation or water surface profile information can be used to estimate average flow velocity. Average flow velocity is usually determined for the bank full elevation using the equation 6, which is V is equal to 1.49 R 2/3 S 1/2 divided by N, where V is equal to average velocity, R is hydraulic radius, S is slope of the hydraulic grade line. Next po. From the hydraulic radius derivations, considered a 2:1 ratio of horizontal and vertical based on figure 2.4. The stream bed width D can be calculated from the stream height Y and stream surface width D by equation 7, while the equation 8 shows how to calculate stream bed with D from stream height Y, which is B is equal to 2 times 2Y plus B, and the lowercase b is equal to 2y divided by and the log time was calculated based on time of concentration as shown in the equation 9. Thank you. Next po.
Good day, I'm Ron Irish, and I'm here to discuss the Chapter 3, Result and Discussion. Chapter 3.1. Chapter 3, 3.1, Pila, San Juan, and Caliraya Watershed Area. Using the ArcGIS flow, the drainage from the digital elevation model was obtained and shown in figure. The rivers and the other stream were determined using the watershed flow line analysis in the table. Based on the ArcGIS watershed area analysis, Pila, San Juan, and Caliraya have one major river each. Its watershed area are 63,692,290.79 meters squared, 173,230,313.3 meters squared, and 128,898,581.3 meters squared, respectively. Here are the Pila, Caliraya, and San Juan sub-basin map. Table 3.1. This table represents the lines detected by the ArcGIS. Pila has a total of 0.449975809 kilometers. This is for the Caliraya. Has a total of 0.773763768 kilometers. And this is for San Juan. It has a total of 1.2 kilometers. There were a total of 176 drainage lines that are detected in Pila, San Juan, and Caliraya, as shown in figure 2.1. Precipitation. The precipitation table were obtained in the World Weather Online. Here it's considered as just the month of August 2021. Here's the month for August 2021. Here is the 2-year precipitation data obtained from the World Weather Online. Hydrograph for 2021. It's worth noting that the peak rainfall occurred in August 11, 2021. There were several peak discharge during the month that were accumulated rainfall events. Here's the hydrograph of the August 2021. Due to serious rainfall of events from August 1 to August 7, Pila recramp for discharge from 3.8 cubic meter per second to 3.24 cubic per second. San Juan has 6.69 cubic meter to 708 cubic meter. For Caliraya has the peak runoff discharge from 4.96 to 5.27 cubic meter per second. Here's the hydrograph or the August 2021 rainfall. Pila predicted volume storm flow in August 2021. The runoff were obtained using the equation 3. Here's the data for the Pila. Here one is data for the San Juan storm flow. The SN were given on the previous table on discussed in chapter 2. For the precipitation obtained from weather online, the surface area was computed using the SI equation. The runoff were computed using the equation 3, and the river basin obtained from the ArcGIS, while the discharge were computed. Same procedure has been done for the Caliraya volume of storm flow on August 2021. Velocity flow type adapted, figure 3.3, show the San Juan River profiles. The river characteristics were obtained from Hydrology Water Research Catalog from Kyoto University. This is the San Juan River profile. It's a figure 3 San Juan River profile. Table 3.8, watershed, river length, and average slope of the river basin obtained from the ArcGIS. Watershed area obtained for Pila, Caliraya, and San Juan. They obtain the river length from ArcGIS, and this one is obtained from the Kyoto University, while this one is obtained also. Table 3.9 show the shallow concentrated flow for the Pila, Caliraya, and San Juan subbasin. Pila has this average slope and surface description of cultivated straight row crops, and they have the velocity equation B is equal to 8.762 times the slope raised to 0.5, which give us the value of 0.9. The same equation were used for Caliraya and San Juan, and they have 1.28 and 0.92 respectively. To determine the open channel segment velocity for the surface description must be identified to determine the Manning coefficient to be used, which is presented in table 3.10. Pila, Caliraya, and San Juan have light brush and trees in summer, which prompt us, the researcher, to use 0.4 to 0.8 Manning coefficient. Time of concentration. To determine the different type of concentration according to the flow segment, each parameter where specific flow segment must be identified. For instance, ship flow, slope and Manning coefficient were determined shown in table 3.11. Table 12 represent the time concentration of the three rivers subbasin. The time concentration were calculated based on the equation 0.5. Manning coefficient obtained based on the sheet flow description, 3.11. Manning coefficient has 0.7. Table 3.12, time concentration for sheet flow segment of Pila, Caliraya, and San Juan. Using the equation, we will able to obtain the time of concentration, which is 0.23 hours, 0.17 hour, and 0.23 hour for Pila, Caliraya, and San Juan, respectively. Present in table 3.13 were the time of concentration per shallow concentrated flow of the river / sub-basin in the Pila, San Juan, and Caliraya. This data is for the time of concentration shallow flow. We able to obtain 0.4 hour for Pila, 0.55 per Caliraya, and 1.2 per San Juan. Table 3.14. The travel time in the channel flow of Pila, San Juan, and Caliraya. Pila obtained a total travel time of 2.03. Caliraya has a 3.42 hours, and San Juan has 4.99 hours. The table 3.15 time concentration of Pila and Caliraya were to obtain the time concentration, where we summarize the sheet flow, concentrated flow, and the open channel flow time concentration, and we're able to get the 2.72 for Pila, 4.14 for Caliraya, and 5.92 for San Juan. Multiplying by 0.6, we're able to get the log time R, which has 1.63 for Pila. Caliraya has 2.48 hours, and San Juan has 3.55 hours. Chapter 4, Conclusion Recommendation, which be reported by Miss Hannah Mayo.
Chapter 4, Conclusion and Recommendation. Next slide, please. Time of concentration is determined by the different responses of a watershed using the velocity method for the three municipalities of the Laguna Lake watershed sub-basins, namely Pila, San Juan, and Caliraya. The following are the analysis and conclusion we obtained from the data we collected. Based on the ArcGIS watershed area analysis, Pila has an watershed area of 63,692,290.79 meters squared. San Juan has 173,230,313.3 meters squared, and Caliraya watershed area has 128,898,581.3 meters squared. According to hydrograph result shown in figure 3.2, which is depicted on August 8, 2021, Pila's peak run of discharge ranges from 3.08 cubic meter per second to 3.24 cubic meter per second. San Juan's peak run of discharge of 6.69 cubic meter per second to 7.08 cubic meter per second, and Caliraya's peak run of discharge from 4.96 cubic meter per second to 5.27 cubic meter per second. A series of intermittent peak discharge occurred from August 14 to 29 due to the series of rainfall events. Shallow concentrated velocities obtained from Pila is 0.90 feet per second, while Caliraya has 1.28 feet per second, and San Juan has 0.92 feet per second. The calculated lag time for Pila is 1.62 hour, for Caliraya is 2.48 hour, and San Juan is 3.55 hour. Next slide. Recommendation. Based on the conclusion of the following study, it is suggested to use the upgraded land use to get curve number in a more precise information. The researchers also highly advise that using the most updated ArcGIS software to get a data that are more accurate for better analysis and for researchers' convenience. And that's all for the report of our group. Thank you.
Here are the reference of our group that we use to obtain the throughout this research paper or group project. Thank you and God bless all. That's all for our group. Thank you very much. That's all.